This is recording 3 for topic 1, and we are now on descriptive versus inferential statistics. So, as I said before, descriptive statistics are used to present data in a way that other people can understand. So, if you see a dashboard with, for example, some college will say how many students and ethnicity and so forth. Sometimes the dashboards tend to have a continually updated presentation of descriptive statistics, right? So number of people who live in Humboldt County, frequency, we'll talk about that, the average age of people living in Arcata, and so forth. Basically, you take a whole bunch of observations and you say something about the sample or the population as a whole, right? Usually it's a sample. And to present descriptive statistics, we might use graphs. We might use measures of central tendency, and we'll get to that in chapter 3, dispersion, correlation, and so forth. Then we have inferential statistics. And these are just the procedures we use to make generalizations about a population from a sample or subset of that population. So for example, in election polling, we ask 1,000 people how they're going to vote to estimate how the whole population is going to vote and to predict the outcome of election day, right? And we're going to see this with hypothesis testing. We're going to start with z-tests, and we'll talk about t-tests, ANOVA, and so forth. Why statistical inference? Well, we can't measure the entire population, so we have to find evidence about the way the population looks or behaves based on our samples. And then we use statistics to test how likely our sample will be given a certain type of population, and we'll get there. So importantly, we need a representative sample. This is one that accurately reflects the individual's behaviors and scores found in the population. Random sampling is the best way to get a representative sample. This just means that all the individuals in the population have an equal chance of being selected to be in that sample. And that can be hard to do. And here's the funny for the day. So for example, people conduct a lot of online surveys. And if you start out with, oh, do you like responding to surveys? Everybody says yes. The rest, no, I tossed them in the bin. Right. Well, they're never getting that. You get the point. We received 500 responses and found that people love responding to surveys. All right. Okay. So more terminology. Variables. Remember, variables must vary. They must take on 2 or more different values. Broadly speaking, we have 2 types of variables. Quantitative variables, which indicate the amount of a variable that is present. So it's numerical, always numerical values or counts like test scores, age, scores on some kind of personality scale, and so forth. A qualitative variable classifies an individual on the basis of some characteristic, like their name, birth month, gender, nationality, ethnicity, right? Categorical. We call these categorical variables. They don't have any order or numerical value. So let's have an example. What kind of things predict voting behavior? Yep. Sex, okay. Age, location, rural and urban voters, people vote differently, I should say. Education, and you could brainstorm others, right? And these are all different types of variables. And we're going to talk about their levels of measurement now, okay? So this is really, really important because levels of measurement determine what statistical analyses we can use and how we can present the data in graphs. Okay, so nominal variables they do have numbers associated with them in your data set because your statistical software needs to be able to categorize them, because nominal variables are categorical, such as gender, right? You can't add, if you assign a 1 to a male and 2 to females and 3 to other, we can't add 1 plus 2 and get other, right? You can't add or subtract. Examples include religion as well. And there's no inherent no order or anything. They're just the numbers. All the numbers do is they code for the names. Ordinal variables are also categorical. The numbers give the order, and you can't add or subtract them either. So, for example, we could have days of the week. You can't add or subtract days of the week, but it makes sense. There is an order, right? Monday, Tuesday, Wednesday, Thursday, months of the year, right? variables that are measured on a simple 1 to 5 point scale that have an order like political orientation, liberal to conservative or conservative to liberal. It doesn't matter which way, but you can think of very conservative on one end and very liberal on the other, and there'll be an order to the progression from one to the other, right? And then we have interval ratio. There are two types. SPSS calls them scale, right? These are quantitative variables. They are numbers. The numbers in them represent a scale of measurement, allowing for addition, subtraction, and so forth. So they can be added and divided and so forth. So nominal scales, number is only a numerical representation of a category, okay? You can think, well, can you add 1 and 1 and get 2? Is 2 more than 1? If it's not, it's going to be nominal, right? So for example, what is your ethnicity? And then you code that as 1 equal white, 2 equals Afro-American, or it doesn't matter. You could have 99 equal biracial, 5 equal Asian American, 650 equal Hispanic. It doesn't matter. The numbers don't do anything but tell your statistical software what category people fall into. It's categorical. Nominal scales are categorical. So for ordinal scales, number is a representation of the order, like day of the week, but again, you can't add or subtract, right? It doesn't mean anything. So for example, in what category does your age fall? Where 1 equals 18 to 24, 2, 25, and so forth. There's a clear order here and it indicates it, but you can't add or subtract them. So with interval ratio scales, number is from a scale with true measurement properties. More of something means more of it, right? 40 inches is half of 80 inches, right? It's meaningful. The data will be collected as such, how tall are you, and then in inches, okay? The only difference, interval variables have no true zero. You can have negative numbers if you want. Ratio has a true 0 point. No negative numbers, right? As far as statistical software goes, for the most part, for your level of statistics, it doesn't matter whether there can be a 0 and so forth. How you ask a question will determine, in some cases, whether data are interval ratio or ordinal, right? Interval ratio generally is not important, but this can be established on how you ask the questions. You can establish a lot of things. It's very important when you're designing research to ask the questions that are going to result in data you can analyze efficiently, right? Now, with psychologists, we generally don't have physical phenomena, so we might measure mindset, like you guys did in that first survey you did last week or the beginning of this week, right? And you had to indicate whether you disagreed or agreed with statements about how changeable intelligence was. So intelligence isn't something you can really change, and you strongly agree all the way to strongly agree with 5 points. You add them up and you get a total score. This is interval data. There is no true zero. You can have negative numbers, you can have positive numbers, so forth. So for example, how do you feel about this class? And I could have you guys indicate on a 10, 11 point scale where -5 means very negative and +5 very positive. Or I could code it like this: 0 is very negative and 10 is very positive. This is largely a matter of preference for researchers. I tend to do 1 through whatever. I don't use zeros because of coding difficulties, and I don't use negative numbers because I don't like to, right? It makes more sense to me to have it the other way, but it's preference. There's no true zero. Another example, you can ask, what is your age in years? And the respondent enters the exact number. Or you could ask which category captures your age, and you have under 18 and so forth. So on the left, you get a scale variable, numerical data, which is purely interval ratio. Now, in this sense, it's more like ratio because there's a true zero, but does anyone answer 0 in your age? No, right? Which category captures your age is going to result in an ordinal variable, right? You can't add or subtract it, but it has an order. So going back to our survey, what kind of data is GPA, right? Major. So GPA, you can have a 0. Okay, it's interval ratio. You can have a 0 as a ratio if you can have a true 0. Don't ever. Major, one psych, 2 other. That's nominal. Income, coded 1 equal under 20K, 2 equals 20, and so forth. This is ordinal. Weight, okay. Ratio, temperature in Fahrenheit, we can have negative numbers, so it's going to be interval. Temperature in Celsius or centigrade, we can have negative numbers, so it's also an interval. Temperature in Kelvin, well, 0 is absolute 0. You cannot have anything colder than 0 Kelvin, so this is ratio. And then you could have interest in psychology, 1, 2, 3. Now, you could sort interest in psychology into a good continuous numerical variable, but this is kind of with only 3 categories. It's going to tend to be discrete and act discrete. So we also can categorize variables as discrete versus continuous. Okay, discrete takes on a small set of values, generally nominal or ordinal, but not always. So, you know, our example of interest in psychology 1, 2, 3, this is, you know, discrete, right? And it is actually not nominal ordinal because you could multiply, you know, if somebody who has a 3 has 3 times 1 interest in psychology. So it's an interval. It can act that way, but it's very discrete, right? Oops. Continuous can take on any value and it's generally interval or ratio, right? So if you have the mindset test, you have a total mindset score of the maximum, it could be, I think there were, I don't remember, but say there's 6 items times 5, you could have 30, anywhere from 6 to 30, right? And you can add and subtract, you can get the mean, right? So forth. So this is really important because level of measurement guides data analysis, what techniques or graphs we use. And we're going to get into that right now, this with graphing. Most outcome variables should be measured on interval ratio scale whenever possible. This facilitates statistical analyses. So it's better to say, what is your age in years rather than in which category does your age fall? Also, because you can always go from interval ratio to ordinal, but you can't go the other way. If you know someone's age is 20, you can then code it as between 18 and 25, but you can't code, you know, you can't go from someone who selects their age between 18 and 25 to 20, right? Get that. Okay. Moving on, relationships between variables. Basically, if there's a relationship, scores on one variable change, when scores on one variable change, scores on the other one do in a consistent manner. The stronger the relationship, the more consistently associated changes in one are with changes in the other. So the strength is the extent to one or close to one value of y tends to be consistently associated with one value of x. We'll look at that. So one-to-one relationship, I created this by just having this is fiction just 1 plus 1. So 0 of fiction is 1 on fiction plus 1, right? This is perfectly consistent. Every change in x has every value of x has exactly one corresponding value of y and so forth. This is a strong positive linear relationship, okay? This slope that goes up, it's a steep slope, strong positive. On the x-axis, we have the number of fantasy authors people recognized, and on the y, number of science fiction authors people recognized, designed to assess reading fantasy and science fiction. So we can see that more or less, like there's a lot of variability because for this value of 0, someone who recognized there's some for a 0 on fantasy, you had one person who also recognized 0 sci-fi, or probably various people, but another person who recognized 1 sci-fi. So there's a little variability here. There's a lot of variability here kind of in the middle, but up here at the extremes, people who recognize 15 fantasy authors recognize either 12 or 13 science fiction, right? So there's not too many different values of y for each value of x. Here we have an example of a weak negative relationship. Negative because the higher the scores in x, which is modal possibility, I won't go into that now, the lower the scores in discuss sensitivity, right? That negative downward slope, right? And we can see that for each value of x, we have quite a range of values of y, even though that tends to be negative. Now, if it's a straight line, a flat line, there's no relationship at all. So here's another scatter plot, and we're going to learn how to do scatter plots later. For scatter plots, you just have one variable on the x-axis. This is extroversion. one variable on the scores and the other variable on the y-axis, which is attitudes towards helmet use in equestrians, which we'll see about. And we can see that knowing the degree of extroversion of a participant here tells us nothing about their attitudes towards helmet use, right? There, for each value of X, there's a lot of values of Y. So no relationship, flat line. All right, let's pause this video. We could do another